Topic is moment of inertia. What is inertia? Inertia means, in general sense, what is inertia? Inertia means, for example, if any body is taken, let me consider a body of mass m only. Okay. If I apply some amount of force on the mass, what will happen then? Then the body will come into the motion. Okay. But here we have Newton's laws. Do you remember them? According to Newton's first law, every body continues to be in the state of rest or uniform motion. That means the body at rest always wants to be at rest only. The body in motion always wants to be in motion. By itself, it never wants to change its state. That type of property, that is not the ability, that is the opposing force, opposing nature. That is the inherent property. The property of that body which opposes the change of state is called as inertia. That point inertia we use, that word inertia we use in case of translational motion. When do we use it? In translational motion. But this is the topic. What is that? Moment of inertia. And this is the topic in case of rotational motion. In rotational motion, we deal with moment of inertia. There, in case of translational motion, already we told that that is the nature which opposes the change of state. And by which physical quantity we can measure the amount of inertia. Inertia is the property, it's not a physical quantity. So we need some physical quantity which decides whether inertia is more or less. What is that measure of inertia? Mass. Very good. Mass is the measure of inertia that we learn in translatory motion. That is in your laws of motion. But here the topic is rotational motion. In rotational motion also, there may be rest, there may be uniform rotational motion. So in that particular case also, the body always wants to be in the same state of rest or uniform rotational motion. The body always opposes to change its state. That opposing property we can measure by using the physical quantity. It is called as moment of inertia. So in that particular case, we use mass as the measure of inertia. In rotational motion, moment of inertia is measure of inertia property here. Okay, whatever the mass plays a role in translatory motion, the same role here we have for moment of inertia in rotational motion. Okay. Now, when it comes to basic formula for moment of inertia. Okay. If you just see here, what I have written here, moment of inertia represents inertia of a body in rotational motion. And it is reluctance which opposes. It is reluctance to undergo a change in its rotation. That means at rest, the body at rest will always wants to be at rest only. In uniform rotational motion, it don't want to accelerate. It don't want to get more velocity or get less velocity. It always wants to move with same velocity. When some amount of force is applied, then there may be some change in the state. Otherwise, it will be in the same state. Now, when it comes to formula for moment of inertia, inertia depends on which factor? Only mass, na? Mass is the measure of inertia. But when it comes to rotation, we need to have, along with mass, some more quantities also will influence here. Okay, those quantities are especially when one particle is taken whose mass is m. What is the mass of particle was taken? M. If this particle is revolving about some axis, about this particular axis, this particle is rotating like this. In that particular condition, moment of inertia depends on, first of all, it depends on mass. Moment of inertia depends on mass of this particle. And also it depends on perpendicular distance between particle, the mass of particle, mass and axis, not the distance. It should be perpendicular distance. That means shortest distance between particle and axis. Axis means physically we should not imagine a line, a line with limited length. We should not imagine like that. Axis means you have to imagine it as a line with a line whose length is infinite. That means you have to take here direction as the reference line, but not simply a single line. Understand? So if particle is taken here, then you can extend this line up to infinite. So you can measure this is the perpendicular distance. Okay. So anywhere you can consider the particle, always you have to take perpendicular distance between particle and axis, especially direction. Okay. So by using those two, the formula for moment of inertia was given as m into r square. That means mass into perpendicular distance square. But basic units and dimension formula you can know. What is the unit? Kg meter square. What is the dimensional formula? M power 1 L square T power 0. Like that you also can write the dimensional formula. This is the basic formula for moment of inertia. And first I will go through some questions related to this formula only. For example, if I consider three particles or 6 particles, individually we have to calculate moment of inertia for each particle, and you have to take the sum of moments of inertia for all the particles, because moment of inertia is just scalar quantity. No need to use any negative sign for the moment of inertia. Always you can use only positive sign. Even any number of particles may be given. For individual particles, first you calculate I1, I2, I3 like that. And finally you have to take the sum of all the moments of inertia. That is the total moment of inertia of that particular system. Understand? Based on that, here some questions were given. You see the first question. If you're able to see that, see the first question then. 4 equal masses, m each, are placed at the corners of a square of length L as shown in the figure. The moment of inertia of the system about an axis passing through A and parallel to dB would be. First of all, masses were directly given in the diagram only. How many masses were given? And each one is having mass m only, na? Each one is having only mass m. That means all the particles are identical particles. And they're all point masses only. They are not spherical bodies. They are not extended bodies. They are simply point masses. Then you can directly use the formula I equal to mr square only, na? So for each and every particle, you can use that formula I equal to mr square. And it was given that all these 4 particles were placed at the corners of a square only, na? Then square also may have some mass, na? But that was not mentioned anywhere. Then if it is not mentioned, you should not take mass of the lines or square area, whatever it may be, that mass you should not take unless and until it was given in the question. Okay, only 4 particles you have to consider. Okay, the positions were given simply And where the how the axis is given here? How the axis is given? Passing through point A and parallel to DB. DB means this one only, na? DB means this one. And it should pass through A and parallel to this one. That means you can indicate this is the line only, na? This is the direction. You can extend up to infinite also. Okay, how much length we need, that much we can draw here. Now, individually for each particle, you calculate moment of inertia. What is the moment of inertia of A? What is the formula for individual particle? Moment of inertia formula? I equal to mr square only. Na? What is the mass of particle A? Small m only given m. What is the perpendicular distance in case of A? 0. Because particle A is on the axis. So perpendicular distance will be 0. So moment of inertia totally will be 0. And for particle B, you see here, again the formula is m into perpendicular distance square. So where we indicate that the perpendicular distance between point B and axis, anybody can draw on the board. You have to show there the distance, shortest distance between particle B and axis. Figure. So this is particle B and this is the line. Shortest distance will be this one only, na? And you have to indicate here length of the body. What is the length of each side given? It was given in the question. L is given. Then what is the length of this part? And square is only given, na? So for diagonal, parallel to the diagonal, this line was drawn. What is the angle here then? 45 degrees. If this is the length L and if angle is 45, then what is this side length? Opposite side length? What is the length of opposite side in the triangle? What is the formula for sin theta? Opposite side by hypotenuse. Opposite side equal to sin 45 into hypotenuse. Hypotenuse length is L only, na? L sin 45. This will be how much? Sin 45 is root 2, 1 by root 2 only, na? So L by root 2 whole square. This will be L square by 2, na? Then it will be ml square by 2. So that is the equation for moment of inertia due to moment of inertia of particle B. And of course, if you see the particle D, that is also at the same distance, na? So the same equation you can write also for particle D. And the remaining one is particle C, na? Now you tell what is the perpendicular distance between particle C and the line? Perpendicular distance between particle C and the line. Anybody can draw that? Draw it on the board. Perpendicular distance. Figure. Perpendicular distance between particle C and axis. Very good. That is the, what is the length of that particular line you have drawn? Length of the that particular line. That is the diagonal only, na? Sit down, sit down. That is the diagonal only, na? What is the diagonal length of a square? Root 2L. If side length is L, what is the diagonal length? Root 2L. So it will be root 2L whole square. So root 2L whole square will be 2L square. So total it will be how much? 2 ml square. Individually for all the mass particles, we have written the equations only. Na? Now, what is the total moment of inertia? Sum of all these four only. Na? So, what is the sum then? I equal to IA plus IB plus IC plus ID. So, IA will be 0. IB will be ml square by 12. So, ml square by 2 plus IC will be 2 ml square. ID will be totally how much it will be? So total moment of inertia of the given system is 3 ml square. So 3 ml square is the answer for this particular question. All of you understand? Okay, now go to the next question related to the same point. These are all the questions given in previous JEE mains examinations only. All of you read the question now. A massless equilateral triangle. Triangle has no mass. Okay. A massless equilateral triangle EFG of side A has 3 particles of mass m situated at the vertices. The moment of inertia of the system about the line EX perpendicular to EZ in the plane of EFG is. Whatever the information given in the question clearly was drawn on the in the diagram only. Okay. See how many particles were taken here? 3 particles. All are identical particles only. Whose mass is? Mass of each one is m only. And length of side is a given. Now, what is the axis given here? About the line EX. About the line EX. Perpendicular to EZ. EX is perpendicular to EZ given. Now, EX in the sense, you can extend the line also. How much we want. So here, for first particle, you calculate what is the moment of inertia due to E? 0 only, na? Because particle E, that particle of mass m at E is already on the axis. So it will be 0. Next, IG at point G. M into what is the perpendicular distance between particle G and this axis? Directly, that is only the distance, na? So side length A na given. So m a square. Next, what about IF? From the particle F, the shortest distance is this much only, na? That is half of the side length only, na? So then how much it will be? M into A by 2 whole square. That will be m a square by 4. So only 3 particles given. For all the 3 particles, we have written the equations. Now total moment of inertia will be sum of these 3 only, na? So that will be ma square plus ma square by 4. How much totally? 5 ma square by 4. Resultant moment of inertia will be 5 ma square by 4. Okay. In last 10 years, directly based on the formula for moment of inertia, these 2 questions were given. Now we can go through the next part in moment of inertia. Till now, just we discussed about only the basic formula and the formula only for individual masses, individual point masses. But now, a large amount of mass distribution is taken. That mass may be distributed along the ring, along the disc, along the solid sphere, hollow sphere, cylinders, whatever may be the shape. Okay. So out of all of this, first I will start my discussion with only ring and disc. Okay. When it comes to ring, see, for every diagram, all are rings only. All these four diagrams indicate only the ring, but different axis of rotation was given. For example, if this can be taken as a rod. If I fix it in the middle, I can rotate it like this. If I fix it at the end, it will be rotated like this. In both the cases, does the same force enough to keep it in rotational motion with same velocity? So even the body is same. If axis changes, what will happen? Moment of inertia will change. That opposing nature also will change. So here also, for the same body, for different axis of rotation, moment of inertia formula will also change. Now, when it comes to the first one, how can we explain this particular axis? The axis passing through center, and this is the plane of ring taken. Plane of ring is taken. If this is the ring, if I consider, this is plane of ring and axis is like this. That means perpendicular to plane of ring. So how can you explain, how can you mention that axis? When a ring is rotated about an axis passing through center and perpendicular to plane of ring. That is moment of inertia due to ring about that axis. Now, about this particular axis, if you see here, since it is a ring, radius is same only, na? It is just a circular, have a circular shape only, na? So from the axis, every mass particle, every portion of that ring is at same distance from this axis only, na? Then this general formula only we can use. What is the formula for moment of inertia in this particular case? Because all the masses are distributed at equal distance from the axis. It is a symmetrical distribution of mass only. So direct formula you can write, what is that? I equal to mr square. Now, when it comes to the second one, see, axis was on the edge of the ring only. How can you explain this? When? How can you explain that? If the ring is rotated about an axis passing through edge of ring, and perpendicular to plane of ring. And of course, the second axis is parallel to the first axis only, na? Then easily you can apply parallel axis theorem. There is a shortcut method we have, parallel axis theorem. Otherwise, you have to take each and every element at what distance from the axis they are distributed, and you have to use integration method, then only you will get answer. But without going to that particular method, directly we can, if you know the equation for the first case, you can know the equation for the second case by using a shortcut method, shortcut theorem, that is okay. So this will be mr square plus m into the distance between these two, again r only. So total mr square plus mr square will be 2 mr square. 2 mr square is the formula for moment of inertia about an axis passing through edge of ring and perpendicular to plane of ring. Okay. Now come to the third case. To explain about the third case, how can you explain the first axis? Very good. Along the diameter of ring. What is the third one? Along the diameter of the ring. To explain that or to directly give the formula, we use perpendicular axis theorem. What is that? Perpendicular axis theorem. For example, if you use three axes for any body, for any plane lamina, you can have three axes. One is along x-axis, along y-axis, along z-axis. So out of these three, you can observe here that two are inside the plane, x and y. Z I have shown perpendicular to plane. About the three axes, we can calculate moment of inertia only. Na? About these two axes, whatever the moment of inertia we get, that sum about these two axes is equal to moment of inertia about the third axis, which is perpendicular to plane. If I consider this is the ring only, this is the diameter, this is the diameter, this is an axis passing through center and perpendicular. Na? That formula is mr square. Na? So mr square should be the sum of moments of inertia about diameter in other two cases. That means about each diameter will be half of the third case only. Na? So what is the formula according to parallax theorem? What will be the formula for moment of inertia about an axis along the diameter? That is mr square by 2. And see the fourth case then. That is tangent. That is called tangent because it is inside the plane. Okay. So this is parallel to the third case axis only. Na? So for the third case, you can apply parallel axis theorem. Then how much it will be? Mr square by 2 plus m into distance between center and the edge will be r only. Na? R square. So how much it will be? 3 mr square by 2. These four are the formulae for ring for the four different cases. If I imagine that all these four cases indicate disk only. For ring, all the four formulae were completed. Now if I come to disk only, the diagrams will be same for ring and disk. On board you can write same, but ring means only there is mass distribution along the circumference. But disk means inside also at every part you will have inside also at every part you will have material here, mass only here. In this particular also axis will be same only. Na? What is the axis taken here? About an axis passing through the center of disk and perpendicular to plane of disk. Okay, na? Now, if you can see that every mass is not at the same distance from center, from axis, because here we have some mass which is at less distance. Here we can have mass which is at more distance. In that particular case, you have to consider a small element of ring. You have to divide the disk into small elements of rings only. Then you have to use some integration method. Then you will get the answer for moment of inertia. In case of disk, if I write the moment of inertia formula, that will be mr square by 2 for the first case. Now, can you answer one question? Which one is easier, to rotate a ring or to rotate a disk? It depends on opposing nature only. Na? Opposing nature is more for which one, ring or disk? For ring it is mr square. For disk it is mr square by 2. Which have more opposing nature? Ring has more opposing nature. Disk has less opposing nature. So moment of inertia less in the sense easily we can change the state. So for disk, in case of disk, it is easier to change the state when compared with the ring. Okay. Now again for the second case, you can apply the parallax theorem only. Na? So what is the formula here? About the center means mr square by 2 plus m into r square. Totally how much? 3 mr square by 2. Now about the diameter, what will happen? It will be half of the first case only. Na? Then how much answer will be then? mr square by 4. And the last one, again you have to apply parallax theorem for the third case. Very good. mr square by 4 plus mr square, totally how much? 5 mr square by 4. Okay. Next few questions I will discuss about moment of inertia of ring and disk. So these are the questions given in last 10 years. All of you just see the question first. Is the question clear? Okay. Consider a uniform wire of mass m and length L. It is bent into a semicircle. Its moment of inertia about a line perpendicular to the plane of the wire passing through the center is. First, a straight wire is given generally, but it was bent into semicircle. I imagine here that was bent into a semicircle like this. What is the length of a semicircle? For the complete circle, it is 2 pi r. What is the length of semicircle? Pi r. What is the length given in the question? L. So what is L given here? Pi r. Then radius will be how much? Then radius r equal to L by pi. Now, in this particular case, if there is a complete ring, for example, and what is the axis they are asking? Moment of inertia about a line perpendicular to the plane of the wire. That means like this. And passing through center. This is the axis. For any particular ring, passing through center and perpendicular to ring, what is the formula? mr square only, na? And we have here a simple formula that even a small portion is cut from the body. The formula does not change. Even a complete ring is taken, the formula is mr square. Semicircle is taken, mr square. Only a simple arc is also taken. For that also the formula is mr square. But which will change? Mass of that body will change only. Na? For the complete ring, mass may be more. For the semicircular ring, that mass you have to write. Understand? Formula does not change even you cut a small part of the body. But because of mass value, the numerical value may change, but formula remains same. So what is the formula for moment of inertia in this particular case? General formula is mr square. M is mass of the semicircle only you have to write. But that was only given in the question. Na? So no need to change it. M. Radius R. But R was not given. So we have written R in terms of L by pi. Na? So you can write M into L by pi whole square, which is equal to ml square by pi square. This is the formula for moment of inertia in case of semicircle in this particular question. All of you understand? Now, come to the next question then. All of you read the question carefully. Totally how many discs are given? 7 discs are given. All are having same mass, na? Same radius, na? That means all are identical only, na? All the 7 given are identical. That arrangement was clearly shown in the diagram. Now the question is, you have to calculate moment of inertia of the arrangement about an axis normal to the plane. About an axis, that means perpendicular to the plane. That means this is the plane of all the discs only. Na? Now axis will be like this. Axis will be perpendicular to the plane of the board and passing through the point P, not at center. They're asking us to calculate about a line passing through P and perpendicular to the plane. But directly edge means it is somehow take more time to calculate. So first we calculate moment of inertia about an axis passing through center. Then you can apply parallel axis theorem. Then you will get the answer. So first of all, I consider about an axis passing through center and perpendicular to plane. Okay, for all the 7 discs only you have to calculate. Now, first one. First for the middle one I will write, total I will write. For the middle one, if this is the axis, what is the formula for disc? Moment of inertia of disc. Since it is passing through center and perpendicular to plane only, na? So that will be, for this it will be mr square by 2 plus for any other disc. For this one, about this axis mr square by 2. About this axis means plus m into this distance square only, na? So mr square by 2 plus m into, what is the distance between this center and this center? R and R, 2R, na? 2R whole square. But in such a way there are 6 discs only, na? So you can take 6 into. Directly we have added all of them. Now what is the answer? mr square by 2 plus 6 into, this is 2R whole square means 4R square. 4mr square plus mr square by 2. That means 9mr square by 2. Totally it is 53 mr square by 2. This is mr square by 2. Totally 55 mr square by 2. That is not the answer, because they are asking us to calculate moment of inertia about an axis passing through point P and of course normal to the plane. But we have calculated for the point for the line passing through O. So from here to here you have to apply parallel axis theorem. Now moment of inertia about a line passing through point P is this passing through center. What is the formula? 55 mr square by 2 plus mass. Mass means the total system mass you have to take. How much is the total mass? 7m. And what is the distance between center O and point P? Here to here R. This is 2R. Totally how much? 3R. So by applying parallax theorem, 3R whole square. This will be 3 3 is a 9, 9 7 is 63, 63 mr square. So by taking LCM, 55 plus 126, that will be 181 mr square by 2. So finally the answer for the given question is 181 mr square by 2. So the many times we substituted the formulae, but only simple formulae. There is no complication in dealing the question, but more number of discs are only given. That's it. All of you understand? Now see the next question then. See the next question. All of you read that. How many discs are given here? 3 are given. Na? About which axis they are asking us to calculate? O dash. See, for first and middle one, how the axis is? It is passing through center and perpendicular to disc only. Na? That means what is the formula? Formula is, for disc it is mr square by 2 plus. For one of the disc at one end, D2 for example, it was just placed like this. It was, for one disc is taken here and other disc is just placed here. What is the distance between this disc and axis? Radius only, na? For this disc and axis, radius. So if you know the moment of inertia about this axis, to calculate about this axis, you can apply parallax theorem. Na? This axis is just a diameter for the ring D2 only, disc D2 only. Na? So what is the formula for moment of inertia of disc about its diameter? mr square by 4. mr square by 4. But they are asking about this axis. So you have to apply. So mr square by 4 plus mr square. But this is for 2 times, na? For on both sides. So into 2. Now, what will be the formula then? mr square by 2 plus, that is 10 mr square by 4, na? 10 mr square by 4. By taking LCM, this is 12 mr square by 4, which is equal to 3 mr square is the answer. Understand? Okay. Whatever may be the diagram, only the question is given on basic formula. Next. Well, if you read the question. Consider two uniform discs of same thickness and different radii. One radius is given r and other is given alpha r. Some alpha times the radius will be for the second one compared to the first one. Made of same material, that you have to identify. Same material has importance. If the ratio of their moment, if the ratio of their moments of inertia I1 and I2. So moment of inertia first one is I1 and for second one it is I2 respectively, about their axis. Whatever may be the axis, but for both of them similar axis only you have to take. And ratio they are asking. See, for the first axis, if the formula is mr square by 4, for next one also mr square by 4, na? So numbers will definitely be cancelled. Na? So whatever may be the axis, it does not matter here. So you have to identify here only the ratio of moments of inertia, I1 and I2, which is equal to m1 r1 square by m2 r2 square, which is given 1 by 16. Are the masses of both same? Which remains same given? Material given same. When radius changes, one becomes bigger and one becomes smaller only. Na? Then will the mass same for both of them? So definitely masses will be different. So, but you can write mass in terms of density into volume. Na? Density equal to mass by volumes and mass equal to. So you can write density into volume means area into thickness. Density is same for both of them. Thickness is same for both of them. But area may be different since radius is different. What is the formula for area of disc? Pi r square. Na? Radius is different. Na? So area also will be different. Into r1 square by, in place of m2, rho. We are not writing rho 1, rho 2 because Density is same for both of them. Thickness is same for both of them. A2 T R2 square equal to 1 by 16. Rho and rho will get cancelled. T and T will get cancelled. Area means pi r square. Na? This is pi r1 square. This is pi r2 square. Pi and pi will get cancelled. You will have r1 square into r1 square. How much? R1 square into R1 square will be R1 power 4 by R2 power 4 equal how much? 1 by 16. Then R1 by R2 will be 1 by 16 can be taken as 1 by 2 power 4. Na? So power 4 will be cancelled on both sides. Answer will be R1 equal to R1 by R2 equal to 1 by 2. Then R2 equal to how much? 2R1. It was given R2 equal to alpha R1, then alpha will definitely become 2. So now the answer for alpha is equal to 2. Understand? Now. Read the next question. Okay. Are you able to see it clearly? Just it will come. How many discs are given here? 2 discs are given here. Are both of these having same dimensions? Are both of these having same dimensions? No. One is having radius capital R, other is having radius small r. Let me consider capital R is greater than small r. One is bigger one and other is smaller one. If mass per unit area, that is nothing but density. Na? In terms of volume, if we consider mass by volume, in terms of aerial objects, in case of aerial objects, we can take mass per area. In case of linear objects, mass per length. So, but it is disk given. Na? So thickness was negligible, so that they have taken only area. So density was taken mass by area. Mass by area here. So that is same for both. What does it mean? Density is same only. Na? Next. For bigger disk, what was the axis taken? Perpendicular to plane of the disk and passing through its center. For disk, what is the formula for moment of inertia about an axis passing through center and perpendicular to plane? What is that? Mr square by 2. M means I consider here capital M R square by 2. Mass is also different, no? So I will take M1 here. Now, this is for the first one. What is the formula for second one? How the axis was taken for the second one? Around one of its diameter lying in its plane. About diameter, what is the formula for disk? Mr square by 4 only. Na? M means I consider M2, right, like that. Small r square by small r square by 4. M2 small r square by 4 only. Now in this particular case, Both the masses are not same only, na? But which remains same given? Which remains same given? The density remains same only, na? That means in place of M1 you can write density into area. In place of M2 density into this area. But here density in both the cases is same, na? If you take the ratio, densities will get cancelled. Area will be there. What is the formula for area? Pi capital R square here, pi small r square here. And of course, pi and pi also will get cancelled. Capital R square into capital R square will be capital R power 4. Here, small r power 4. And 2 by 4 reverse aipote 4 by 2. That means answer will be 2 into capital R power 4 by small r power 4. Okay, I'll go to the next question now. See here, 4 identical discs each of mass m and diameter a are arranged small plane as shown in the figure. The moment of inertia of the system about O dash is. Okay, this is also simple question. See how the discs are arranged here. 2 discs directly on the axis. That means for this disc, axis is about the diameter. For this one also about the diameter. For this one, about tangent only. So for each one, you can write the formula only. Na? For the upper part, what is the formula you can write? I equal to M for disc only. Na? For disc about diameter, mr square by 4. And for this one also, mr square by 4. And for this one, by applying parallax theorem, mr square by 4 plus mr square. For the fourth one also 5 mr square by 4. Totally how much then? 5 plus 5 10 plus 2 12. 12 mr square by 4 which is equal to final I value will be 3 mr square. Understand? Now see the next topic now. This is for solid sphere and hollow sphere. For solid spheres and hollow sphere also, here we should know about the formulae for moment of inertia. The previous ring and disc, they are two-dimensional objects. So they have one axis along the diameter, other is perpendicular to the plane. But sphere means three-dimensional object only, na? So no need to give separately about the plane and perpendicular to the plane. Every axis is only along the diameter here. In all the three dimensions, x inner diameter, along y-axis it is diameter, along z-axis also it will be diameter only. So if it is solid sphere, here the formula will be about diameter. The formula will be 2 by 5 mr square. About any other axis along the tangent, parallax theorem you can apply, na? About this axis it is 2 by 5 mr square. About this axis, if the distances are here, then 2 by 5 mr square plus, by applying parallax theorem, this will be how much? For hollow sphere, what is the formula? 2 by 3 mr square. And this will be 2 by 3 plus 2 by 3 mr square plus mr square. How much? 5 by 3 mr square. See here, which will have more hello. Okay. Okay. Now come to the next question. Two identical spherical balls of mass m and radius r each are stuck on two ends of a rod of length 2r and mass m. Okay, spherical balls are given whose radii are, here radius r, here is radius r, here also radius will be r. Mass here and here in both the cases m only. But the length of the rod is given 2r. And rod is also having some mass. Moment of inertia of system about the axis passing perpendicularly through the center of the rod. That means this is given in the question only. See, for rod, what is the moment of inertia formula about an axis passing through center and perpendicular? That is ml square by 12. What is the formula for rod? ml square by 12 means 2r only, na? So m into 2r whole square by 12. 2r whole square means 4r square, na? So it will be mr square by 3. mr square by 3. For this particular sphere, solid sphere only, about this axis, if nothing is given either solid or hollow, mostly you have to take only solid sphere. Even simple sphere is given, you have to take it as solid sphere. So for this particular sphere, about its diameter, what is the formula? 2 by 5 mr square. But about this axis they are asking us, so you have to apply parallel axis theorem. So what is the formula then? 2 by 5 mr square plus m into here to here r, and here to here is also r only, na? Total length of the rod is given 2r, na? So r plus r 2r whole square. How much it will be? This is 4 mr square. This is 2 by 5 mr square. So 22 mr square by 5. And of course for this third one also we will get the same formula, na? 22 mr square by 5. By adding all these three, this is the sum of these two will be 44 mr square by 5. 44 mr square by 5 plus mr square by 3. How much it will be? 132 mr square plus 5. 137. 137 mr square by 15. 137 mr square by 15 is the correct answer. Understand? We have taken individually like three bodies. Solid sphere and rod only. Based on that we calculated the formula. See that? The moment of inertia of a solid sphere about an axis parallel to its diameter and at a distance x from it is I. Which one of the graphs represent the variation of I with x correctly? This is also a question given in previous JEE examination only, but I have not given here all the options. But now we have to draw the graph for the given question. Let me consider that this is y-axis and this one is x-axis. Okay, on x-axis you can take the distance, on y-axis you can take moment of inertia. About which axis they are asking here? Parallel to its diameter. If any sphere is taken like this, parallel to its diameter, this is the diameter at distance x. You can apply parallel axis theorem only, na? What is the general formula? 2 by 5 mr square plus m into x square. That is equal to final moment of inertia. Okay. I is on y axis. X is on x axis. Distance is on x axis. But this is the constant value only, na? So initial y component is not 0. Y component starts from 2 by 5 mr square. And remaining I is proportional to x square only, na? So the graph starts from some value. Here, what is the value of I? 2 by 5 mr square. And from this point, it is directly proportional to x square only, na? So that is the graph between I and x. Understand? Now, a solid sphere is taken whose mass is m and radius is r. It is divided into two unequal parts. What about the first part given? The first part has a mass of 7m by 8 and is converted into uniform disk of radius 2r. Okay, first I will go through the first part only. I will first calculate that. Okay, now I1, it was given I1. So the first part has a mass of 7m by 8 and it was converted into uniform disk of radius 2r. If that much mass, what is the general formula for uh, moment of inertia of disk? About which axis they are asking? I1b, the moment of inertia of disk about its axis. That means axis passing through center and perpendicular to plane. What is the general formula? mr square by 2 na? M means 7m by 8 into r means 2r whole square by 2. How much it will be totally? 2 to the 4. 4 means 7m by 4, 7 mr square by 4, I think. You also just calculate 7 mr square by 4. What about I2? The second part is converted into uniform solid sphere. But radius was not given, na? See, radius was not given. So 7m by 8 mass is removed. What is the mass of remaining part? M by 8 only, na? Okay. If mass becomes 1 by 8 times and it remains as a solid sphere only, then how will the radius change? Volume is equal to 4 by 3 pi r cube. Na? If mass becomes by 8 times, radius becomes by 2 times. Radius becomes by 2. So what is the formula in case of solid sphere? 2 by 5 mr square. What is m? M by 8. What is the radius? Here it is important. R by 2 whole square. Then what is the final answer here? mr square by 4 8 32 into 5. 16 into 5, 80 only na? 80 na? 80 only. 2 and 2 will get cancelled there. This is I2. Ratio they are asking. 7 mr square by 4 by mr square by 80. That ratio is just mr square will cancel. Then I1 by I2 is equal to 7 by 4 into 80. By 1 by 80 na? Into 80. This will be 140. So ratio will be equal to 140. 140 is the correct answer. Understand? One large solid sphere is divided into two parts. One mass is 7m by 8, other mass is m by 8. See this question? All of you read it. There are three axes here. One triangle was made here and ABC were mentioned there. This is IO. This is IO. This is IA. IO. IA. The point O will be here. Here O will be. This is A. Three solid spheres, each of mass m and diameter d. It was not given in terms of mass. It was given in terms of diameters. Not in terms of radius. Given in terms of diameter d. Are stuck together such that the lines connecting the centers form an equilateral triangle of side of length d. That side length also d, because this indicates diameter only, na? This radius plus this radius, totally diameter. The ratio IO by IA of moment of inertia, if IO of the system about an axis passing through the centroid, that means this O. This is the centroid for the triangle. And about center of any of the sphere, IA and perpendicular to the plane of the triangle. So, what about IO first of all? What is the distance for each sphere? For each sphere, you separately have to calculate. About this axis, that means diameter only, na? What is the formula in case of each solid sphere? 2 by 5 mr square. But about centroid means what is the distance between centroid and corner of the triangle? L by root 3. What is the distance between corner of the triangle and centroid will be L by root 3 in case of equilateral triangle. That means m into L means here diameter, na? D by root 3 whole square. Side length is D na here. D by root 3 whole square. Then what is the answer then? And this is for one sphere only. But for the three spheres you have to calculate, na? Then this is the answer. So 3 into 2 by 5 mr square plus, you better convert radius into diameter only. In place of radius you can write d by 2 na? So d by 2 whole square na? That means 2 md square by 4. That means md square by 10. Md square by 10. This is md square by 3. That will be 13 md square by 13. 13 md square by 30.